it all?
Morning, welcome to fall meeting day 2. We're very happy to have the Arctic Report Card here with us again this year. Just a reminder to those who are following us online, you can put your questions, if you are a reporter, into the Q&A box at any time. And please indicate if you would like us to read the question for you, or if you would like us to invite you to open your mic and ask the question live. And just a reminder, because I know we have a lot of scientists today, that these questions are for reporters only. We want to make sure we get to everyone today, although we do have a little extra time. So I expect that we can run until 11:15 for Q&A. And I think with that, I'm going to introduce Dr. Svinrad to give an introduction to the panel.
Thank you for that introduction, Liza, and thank you all for being here today as we release NOAA's 2022 Arctic Report Card, continuing a long tradition and series of report cards. In fact, just as a sidebar, I was talking with some of the panelists that I remember doing this when I was NOAA's chief scientist back in San Francisco. It must have been about 8 years ago. So I'm glad to be back here in person to be able to serve in this role. The Arctic Report Card is an annual volume of original, peer-reviewed environmental observations and analysis to document the rapid and dramatic shifts that we're seeing in weather, climate, terrestrial, and oceanic conditions in the circumpolar region. And today marks the release of the 17th Arctic Report Card, which is a comprehensive assessment with contributions from 147 scientists representing 11 different nations, and including many representatives from a wide variety of U.S. federal agencies, including NASA, Department of Energy, U.S. Geological Survey, U.S. Fish and Wildlife, the Bureau of Land Management, and the National Park Service. Over the years, the American Geophysical Union has been a key partner for NOAA, and I'm pleased that we're able to release the report card here in Chicago at the AGU fall meeting. Insights about the circumpolar region are relevant to the conversation about our warming planet now more than ever. We're seeing the impacts of climate change happen first in polar regions. We're also seeing the ways in which communities, businesses, and institutions are innovating and adapting to the effects of climate change. This past summer, I had the chance to spend a significant amount of time with our NOAA colleagues and partners in Alaska. And my biggest takeaway from that trip is that the wolf is in the house. By that, I mean the climate impacts we're seeing in Alaska: melting permafrost that's warping roads, melting ice that's forcing entire indigenous communities to relocate, warming waters that are forcing fish to migrate and are having ripple effects for the entire Alaskan seafood industry, fire seasons that last far longer than they ever have. That's just a snapshot of what parts of the lower 48 might expect in the very near future. We need to look to polar regions and understand what's happening there through data, observations, modeling, predictions, to get a better sense of how we can build a climate-ready nation that encompasses all 50 states. It's this need and prioritization of Arctic issues that compelled me to elevate the attention within our own agency to the highest levels of political leadership within the organization. I'm delighted that Dr. Kelly Chris is with us here today. Kelly serves in the capacity as Deputy Assistant Secretary for International Fisheries, but is also our lead for NOAA's attention to Arctic issues. From this year's card, you'll get an update on seven vital signs, including air temperature, snow, sea ice, Greenland ice sheet, sea surface temperature, ocean plankton blooms or primary productivity, and tundra greenness. In addition, we've added a new vital sign on precipitation. This is a testament to the significant increase we've seen in precipitation events in the Arctic as the climate warms. This year's report also includes a chapter on the consequences of rapid environmental change on people. I cannot overstate this, but rapid warming in the Arctic is profoundly affecting the more than 400,000 indigenous people who live there, and in many instances is upending their entire way of life. This September, for example, a historic tropical storm The remnants of Typhoon Merbok lashed western Alaska, bringing flooding, erosion, and crippling power outages. The impacts of this and increasing coastal storms go beyond the physical losses, affecting the food security, the health, and the cultural traditions of Alaska natives, which were severely jeopardized by this aberrant storm. Storms like these may not remain outliers, underscoring the need for us to build our resiliency to the climate impacts we cannot avoid. As such, NOAA is working to develop our part of the nation's new national strategy for the Arctic region, which focuses on addressing the climate crisis and supporting the livelihoods of people in the U.S. Arctic. This is being carried out in part by the Council on Economic Quality and the Office of Science and Technology Policy's new government-wide guidance and an accompanying implementation memorandum for federal agencies on recognizing and including Indigenous knowledge in federal research, policy, and decision-making. The Biden-Harris administration has formally recognized Indigenous knowledge as one of the many important bodies of knowledge that contributes to the scientific, technical, social, and economic advancements of the U.S. and our collective understanding of the natural world. Another example of our collective Arctic work includes the recently launched pilot project with the Alaska Native Tribal Health Consortium to boost Alaska Native communities' resilience to climate change. And I'm delighted to join Jackie Schaefer on our panel here today. And I will take a quick note to congratulate Jackie on her very recent promotion to Director of Climate Initiatives at the consortium. Congratulations, Jackie. Projects like these are made possible through the bipartisan infrastructure law and the Inflation Reduction Act, which gives us historic resources to make the needed investments that accelerate climate preparedness, both in the Arctic and throughout the country. NOAA will use our BIL and IRA funds in part to restore coastlines, protect food security, and help manage natural resources so that Alaskans living on the front lines of climate change can better plan for and adapt to what lies ahead. Just last week at NOAA, along with our partners at the National Fish and Wildlife Foundation, announced a key set of grants made possible in large part by the bipartisan infrastructure law, with a total conservation impact of nearly $250 million. 5 of those grants announced last week will go to Alaskan entities to fund work such as nature-based solutions for resiliency, wetland and salmon habitat restoration, and other coastal resiliency strategies. And I'll add that it's our intention to apply significant resources in the future in the formal budget process that we go through in the federal government. So before I hand the microphone off to Arctic Report Card editor Matthew Druckenmiller for the presentation of the 2022 Arctic Report Card, I believe we have a short video to kick it off. Thank you.
Human-caused climate change is having an ever-increasing and profound effect on the Arctic. From the ocean to the air, warming trends are continuing, and air temperatures in the Arctic are rising faster than the global average. In 2022, average annual surface air temperatures were the 6th warmest since 1900, with the 10 warmest years all occurring since 2011. Sea ice is thinning, far below conditions that existed 30 years ago, and older ice remains scarce. This loss of sea ice has enabled more shipping through the Bering Strait and Beaufort Sea, bringing with it more human-made debris, increased underwater noise, and the risk of potentially catastrophic incidents, such as oil spills. All of this activity has wide-reaching impacts on Arctic ecosystems. Seabirds are natural indicators of the health of marine ecosystems, and in 2022, Bering and Chukchi Sea communities reported the 6th consecutive year of seabird die-offs, most likely due to starvation, and coinciding with the loss of ice in those areas. Prior to 2015, seabird die-offs were rare in Alaskan waters and were usually wintertime events linked to disease outbreaks and above-average ocean temperatures. And both of those factors are projected to increase in coming years. Rainfall has also been increasing and likely transforming Arctic regions from snowfall to rainfall-dominated climates. In 2022, this was most apparent in eastern Greenland, Svalbard, and northern Norway, and in the central Arctic, with more consecutive wet days generally coinciding with reduced sea ice coverage in warmer months. Extreme weather, from heavy rainstorms to drought, has become more frequent, and the impacts of these events can be disastrous. At the peak of an unprecedented September heat wave over Greenland, more than 1/3 of the ice sheet's total surface was melting. A potentially large source of sea level rise is melt from the Greenland ice sheet. As warmer air and warmer water continue to melt the ice, impacts to ecosystems and communities within and far beyond the Arctic are already underway. The evidence is clear. Human-caused climate change is transforming the snowy and icy Arctic into a warmer, wetter environment. To limit these harmful consequences to the Arctic and beyond, it is essential for society to reduce greenhouse gases worldwide.
Good morning. My name is Matthew Druckenmiller. I am a research scientist at the National Snow and Ice Data Center. And on behalf of the Arctic Report Card lead editors, Rick Toman, Twyla Moon, and myself, and the Report Card's coordinating editor, Kale Ulig, I want to first just express our gratitude to the many diverse contributors to this year's Arctic Report Card. It is truly an international collaboration, and increasingly a collaboration that involves Arctic Indigenous peoples and community members, which is absolutely necessary to capture the scale of the physical and ecological changes that we're seeing across the Arctic, as well as what it means for peoples within the Arctic and beyond. The human-caused warming of our planet is amplified in the Arctic. Over the last 3 decades, the Arctic has warmed at least 2 to 3 times faster than the global average. For this past year, surface air temperatures in the Arctic were the 6th warmest since records began in 1900. And importantly, the last 7 are the warmest 7 years on record. Surface air temperature is one of the 8 Arctic vital signs that the report card assesses each year. And as Dr. Spinrad just mentioned, these 8 vital signs now includes precipitation, which contributing lead author John Walsh will discuss here shortly. The report card's vital signs provide a view into the state of the Arctic system, which is characterized by extreme shifts in temperature, land and ocean cover, and ecological processes. These extreme shifts across the annual cycle are a source of the Arctic region's heightened sensitivity to climate change. With this sensitivity, change in the Arctic is accelerating, as is shown here in this slide. With this warming, seasons are shifting, and climate-driven disturbances such as wildfires, extreme weather, and unusual wildlife mortality events become increasingly difficult to assess within the context of what has been previously considered normal. Therefore, this year's report has implemented a new climate baseline period across our vital sign essays. In alignment with NOAA and the World Meteorological Organization, the report card now uses 1991 to 2020 as the new 30-year baseline, updated from the previous 1981 to 2010 reference period. With this shift, we are better able to assess accelerating change and disturbance. Seasons are shifting in the Arctic, altering ecological and landscape processes, and increasingly misaligning with human expectations. The snow season, especially in spring, is declining at a rate of nearly 20% per decade. marking a dramatic shift in how the snow season is defined and experienced across the North. Not only do we see a shift in the transition from spring to summer, but we also see an expansion in summer itself. Annually, the Greenland ice sheet accumulates mass in winter through snowfall and loses mass in summer. Scientists from across the world assess this delicate balance. This year, we found that the Greenland ice sheet continued its streak of net ice loss for the 25th consecutive year. Observations are showing an ice sheet out of balance. In early September of this year, in 2022, the Greenland ice sheet experienced an unprecedented late season melt event across 36% of its surface. This was followed by a smaller but still unprecedented event late in September, caused by the remnants of Hurricane Fiona moving up along the eastern coast of North America. This is challenging how researchers define the Greenland summer melt season. Surface melt driven by warming air temperatures plays a critical role, but we are increasingly learning about the transformative role that warming waters play. This year's report includes findings from the NASA Oceans Melting Greenlands mission that has confirmed the important role that warming ocean temperatures play in influencing ice loss at the ice sheet's margins. Human-caused warming in the Arctic has global consequences. Rising seas are a reality for coastal communities and societies worldwide. The Arctic Report Card's vital signs, like the Greenland ice sheet, track changes in the physical and ecological features of the Arctic, but they alone cannot tell the story of how change is impacting people's health and well-being. For this, the report card increasingly is looking to Arctic peoples to share how they understand, experience, and deal with change. Not only isolated events like storms, but also the cumulative impact of Arctic and global change across years and increasingly across decades. We are happy to have Jackie Schaefer here to contribute this important perspective today. One of the more powerful examples of how a change in Arctic relates to societies worldwide is Arctic shipping. This year's report details how the emergence and availability of satellite-based ship data since 2009 is helping to assess how the opening of the Arctic Ocean is driving more ships into its remote and ecologically sensitive waters. As of 2022, satellite-based records reveal increasing maritime ship traffic within all Arctic high seas and national exclusive economic zones. These findings align with the expectation that Arctic shipping will continue to increase as sea ice diminishes. And it's on this topic of changes in sea ice and in the marine environment that I'll now pass it on to one of the Arctic Report Card's lead authors, Karen Fry.
Thank you, Matthew. I'm Karen Fry, a polar scientist in the Graduate School of Geography at Clark University in Massachusetts. My research combines the use of field measurements, satellite remote sensing, and geospatial analysis to study large-scale linkages between land, atmosphere, ocean, and ice in polar environments. This year's report card shows that Arctic sea ice extent in 2022 was similar to 2021 and well below the long-term average. The extent of multi-year ice, or the ice that has survived at least one summer melt season, recovered after near record low levels in 2021. However, it was also still well below multi-year ice extents measured in the 1980s and 1990s. The oldest sea ice, greater than 4 years old, continued to be extremely scarce across the Arctic region. Open water did develop near the North Pole through much of the summer of 2022, and the Northern Sea Route and Northwest Passage were largely opened, allowing for easier access for ship traffic. Sea surface temperatures during August show warming trends from 1982 through 2022 over most of the Arctic Ocean. While trends for the entire Arctic Ocean have exhibited warming trends of 0.3 degrees Celsius per decade, regions like the Chukchi Sea has seen warming of 0.5 degrees Celsius per decade over the 41-year record. In the Barents and Laptev Seas in the Eurasian Arctic, August 2022 mean surface temperatures were 2 to 3 degrees Celsius warmer than the 1991 to 2020 mean values. Declines in sea ice and warming seawaters across the Arctic Ocean have also contributed to increasing rates of primary productivity, or the growth of microscopic algae that makes up the base of the entire marine food web. In particular, earlier seasonal sea ice breakup in the spring and later sea ice formation in the fall allows for more light availability and therefore a longer growing season of marine algae across the Arctic Ocean. The strongest increasing trends have occurred in the Eurasian Arctic and Barents Sea. Since 2003, primary productivity in the Eurasian Arctic has increased by 62% and in the Barents Sea by 18%. During 2022, 5 of the 9 regions across the Pan-Arctic showed higher values compared to the 2003 to 2021 mean. Monitoring changes in marine algae growth is important for understanding how upper levels of the marine food web, including fish, marine mammals, and seabirds, are impacted as well. This year's report also includes 2 updates on bird populations across the Arctic. During 2022, the Northern Bering and Southern Chukchi Sea region reported the 6th consecutive year of higher than expected numbers of dead seabirds, which were found along broad reaches of Alaskan coastlines. The birds were found to be emaciated, which was the most significant factor contributing to these deaths. Exposure to biotoxins from harmful algal blooms and avian influenza are also currently being investigated. Seabirds and their eggs are important food for rural Alaska, and residents are concerned about the loss of these subsistence foods. The chapter authors note that community members and tribal leadership throughout the Bering Strait region have been working closely with state and federal scientists by reporting observations of dead and dying seabirds since the die-offs began in 2017. This year's report card also includes the first ever report on Arctic geese populations of North America. In 2022, despite an outbreak of avian influenza in North America and variable spring weather conditions, the population sizes of most Arctic geese remained at or above historical levels. With that, I will pass it on to Dr. John Walsh, who will speak about precipitation events.
Thanks, Karen. I'm John Walsh from the International Arctic Research Center at the University of Alaska Fairbanks. As previous speakers have mentioned, this year's report card includes precipitation, Arctic precipitation, as a vital sign for the first time. Precipitation is indeed a vital part of the Arctic system. It drives surface hydrology, including river runoff. It drives the snowpack, and it contributes to ocean surface salinity. Our assessment used 2 main sources of information. One was direct measurements of precipitation from Arctic observing stations. The other was a state-of-the-art atmospheric reanalysis. So among the highlights, wetter than average conditions prevailed over the Arctic during the past year. For the Arctic as a whole, the past 12 months, the 12 months ending in September, was the 3rd wettest 12-month period since 1950. The only wetter years were 2018 and 2020. Let's see. The report card's essay on snow shows that the end of the winter snow mass in the Arctic was unusually high over both North America and Eurasia. In fact, the recent average of the end of winter or April snow mass over North America reached a new high this year. But the warmer springs mean a rapid disintegration of the snowpack, leading to the negative trend in June snow extent, as Matthew showed. Consistent with the recent high precipitation years, here we are, we found that total precipitation now shows a statistically significant trend in the Arctic. This increase is statistically significant in all 4 seasons and in both of the data sets that we used. And the data sets are largely independent of each other. We also looked at trends in heavy precipitation events. As an example, Utqiagvik in northern Alaska had its wettest day on record just this past July. Over most parts of the Arctic, there are positive trends in the year's heaviest 1-day and 5-day precipitation amounts. This is especially true in the subarctic North Atlantic, while the number of consecutive wet days is increasing over much of the central Arctic. Extreme events can include snow, rain, and in a warming Arctic, freezing rain. There we go. As an example, in a single event this past December, Fairbanks received over 35 millimeters, that's 1.4 inches of freezing rain. In the Arctic, these freezing rain events can be devastating because the ice layer can persist for months until the spring thaw. The ice remains on roads and it can prevent foraging by wildlife. Finally, we address the question of what's responsible for this increase in Arctic precipitation. There are several candidate explanations. One is the greater moisture availability as the open water season lengthens and sea ice retreats over the Arctic seas. The trends that we found or that we show in map form do tend to show that the maximum significance of the increased precipitation is in the regions of the ice margins. A second factor is the atmosphere's increasing capacity for moisture as the Arctic warms. And finally, Arctic storminess may be increasing, at least in some parts of the Arctic. Whether or not the frequency of storms is increasing, storms are passing over more open water in the Arctic and over warmer water prior to reaching the Arctic, favoring cyclone or storm intensification. For example, ex-typhoon Merbok this past September, which Dr. Spinrad mentioned, was a high impact event in Alaska. This slide shows how this storm passed over unusually warm water in the North Pacific before it reached Alaska. The water temperatures in red on that, in the left panel on that slide, were the highest on record in those parts of the North Pacific. So with that mention of a high impact event, I will pass it on to our final speaker, Jackie Schaefer. There we go.
Thank you, John. Uvlalortak, pakulgifsi, vanga atika Catalonia, inipainurunga, anirunga ke kiktagrumi. Anayakaka makiklu kipkenyalu, atataka iglukuklu, agutuklu, mayuklu, floydlu, savaktunga ANTHC. Nalagmechiska, Jackie Schaefer. Good morning. I am Jackie Catalina Schaefer. I am the climate director for climate initiatives. And this recent partnership with NOAA is a response to what's happening so rapidly in the Arctic. I'm also the co-PI on the human well-being team for the study of environmental Arctic change. Search. The search essay produced resulted from a series of facilitated discussions over the course of a year among 42 authors. Search co-produced this essay, resulted in a series of facilitated discussions. Each team balanced a mix of scientific, Indigenous, and decision-making experts. Our teams include 3 teams: the International Cooperation and Economic Decision-Making Team, the Human Wellbeing Team, and the Drivers and Ecological Consequences of Rapid Changing Arctic Team. I was born and raised in Kotzebue, an Inupiaq community on the Chukchi Sea and Northwest Arctic in Alaska. My community is one of many across the Arctic that is bearing the brunt of climate change impacts as detailed in the Arctic Report Card and in national and international assessments. Our homes, livelihoods, and physical safety are threatened by the rapid melting ice, thawing permafrost, increasing heat, wildfires, and other changes tracked by the Arctic Report Card. The consequences for people of rapid environmental change in the Arctic are the subject of the final essay in this year's report card. More than 40 Indigenous, scientific, and decision-making colleagues came together in search to describe how people experience these changes and consequences in the Arctic. A key takeaway of our efforts to date is that people experience the consequences of these extremes not as individual events, but as a composite of multiple events. Each community is affected by a unique combination of physical conditions, responses of biological resources, impacts on infrastructure, decisions influencing adaptive capacities, and both environmental and international influence on economics and well-being. Arctic Indigenous people interact intimately with our environment, and our safety depends on knowing how to operate on land and sea. The distribution, quality, thickness, and timing of ice on the ocean, lakes, and rivers drive nearly every aspect of life in the Arctic, from boating to whaling to seal hunting to the safety of fishing and foraging. Search recognizes that Indigenous and scientific experts know a great deal about the Arctic environment, but the information is not readily accessible to decision makers. Therefore, we are facilitating a complex collaboration of diverse experts to combine and share their understanding with multiple audiences, Indigenous people. And as an example, typically Indigenous people share and process knowledge orally. So we invited my dear friend and mentor, Wilson Justin, and Atna Dene storyteller, to share his experience and knowledge of climate change in the recording that accompanies our essay. That essay synthesizes in a more Western format a year's worth of deliberations among the search team members. Our brief essay scratches only the surface of the compound impacts to people of the rapid Arctic change. As we expand our efforts, we are mindful that addressing unprecedented Arctic environmental changes requires hearing one another, aligning our values, and collaborating across knowledge systems, disciplines, and sectors of society. The beauty of our stewardship over this land is captured in a quote by another dear friend, a retired professor, Paul Onteguk. He states, "We lived in places with such efficiency and grace that later people who have come to our homelands have considered them to be empty of human beings. And they've called this a wilderness because they didn't see us in this place. They could not imagine that a people could live so well in a land that it would appear untouched by them." And we live with that dilemma today.
Thank you very much, Jackie, Karen, and John. I'll just end by again acknowledging that this year's report was really the work of so many people, 147 contributing authors from 11 different countries. We covered a lot of the topics in the report on this panel, but there are many more topics and highlights in the report. And so I encourage you to take a look and dig in. For example, one very unique contribution this year is on the role of Arctic pollinators and most importantly, international efforts to come together to begin to understand those populations across the Arctic. The Arctic is a very varied and expansive region to monitor. And I think the one thing that the report does this year is emphasize that international partnerships, as well as partnerships with Arctic Indigenous peoples, is really critical for us to be able to both understand and observe the change, but also to come together and try to identify what some of the solutions are to these long-term climate impacts that are unfolding. So with that, I think we are moving into the question and answer session that Liza will moderate for us.
That's right. Thank you so much, panelists. We will open the floor now to questions from reporters here and online. And you see John is modeling, raise your hand if you have a question in the room. And if you are online, please put your name into the Q&A box, not the chat, but the Q&A box, and indicate if you would like us to read your question or we can open your mic for you. As you said, we have some of our panelists, or many authors available online and in the room today too. So I'm going to rely on you all here to point out your colleagues if you think that question should be directed to them, and we will find them. I think we are also promoting one of your authors to panelists online, so you will see them if you are on the Zoom. I'm going to start with John.
Hi, it's Jonathan Amos from the BBC here. There is a dearth of ground weather stations, in particular rain gauges as well, across the world, never mind the Arctic. So I'm just wondering if you could explain to us really how you've put this precipitation data together, because it can't be easy, right? I don't know how many rain gauges there are in the Arctic, but there aren't many. I'm sure of it. So yeah, if you could explain them.
Suppose that one's for me. It is a sort of a central question to the precipitation chapter. And that's the reason we use two different data sets. As I mentioned, one of them was a synthesis of the station observations, in which the Global Precipitation Climatology Center tried to synthesize those reports and interpolate them across the northern land areas. But that misses the oceans, and the oceans are a big part of the Arctic. The other source was this, what we call an atmospheric reanalysis, which is essentially a model that assimilates observations of temperature, precipitation, and wind around the world, everywhere. And it produces precipitation. It generates precipitation everywhere, land and ocean. So that gives us truly complete coverage of the whole Pan-Arctic. And what that trend map showed, or trend diagram showed, was that the two sources were surprisingly consistent. Both of them showed changes on the order of 10 to 15% over the period since 1950, and the ups and downs from year to year coincided in both. So that gives us some confidence that reanalysis, which admittedly is model-based, is able to capture what's being recorded on the ground, and it adds value in a sense. But we did come up with a surprisingly consistent picture from two sources.
We'll take a question online and then we'll go to the gentleman here.
Hello, can you hear me? All right, this is Janessa Duncombe from AGU with EOS. I was confused about the changing climate baselines. What do you mean about changing the climate baseline that's used in the report? And what does that mean about comparing this report to past reports? And why are you moving the baseline? Thank you.
Yeah, thanks for that question. I will answer that. Then I also would like to turn to one of the other editors of the Arctic Report Card, Rick Toman, who's online, who might be able to fill in the gaps in my answer. So as mentioned, we updated the climate baseline to 1991 to 2020. And so what this baseline allows us to do, what all baselines allow you to do, is to calculate departures from normal anomalies across the different things that we are observing and measuring throughout the Arctic Report Card. One of the things that we have maintained within the report is still record rankings. So for example, we showed surface air temperature, the sixth warmest in the historical record going back to 1900. That's independent of using the climate baseline. Again, those baselines are really important for looking at departures from what we may call normal. And so by updating our climate baseline from the previous, which has just shifted it by 10 years, allows us to somewhat establish a new normal to compare to, understanding that change is consistent, and updating these baselines, it allows us to essentially calibrate how we assess departures from normal. I will turn it to Rick Toman, who's online, who might be able to further offer some explanation.
Thanks, Matt. Can you hear me?
Yes, we can, Rick.
Okay, so with that explanation, I would also point out that, as you may know, NOAA transitioned to the 1991 to 2020 climate baseline period last year, and the World Meteorological Organization has transitioned that to the recommended period for calculating departures from normal. So the Arctic Report Cards move is keeping in line with organizational recommendations on how to think about how our most recent, in our case, year is relative to the relatively modern baseline. Now in the Arctic, things are changing so rapidly that we still have part of the old climate in there, but we're following the recommendations of scientific organizations in updating our baseline. Thanks.
And I'll just briefly point out that this is not the first time that baselines have been updated. If you look back at studies of surface air temperature, other variables in the Arctic, baselines have been updated in the past for sure.
Hi, this is Andrew Friedman from Axios. I just have 2 quick questions, or maybe one of them is not as quick. We hear that the Arctic is warming 2 to 3 times the rate of the rest of the world pretty frequently. A study this year found that it was more like 4 times the rate of the rest of the world. I know some stories on our website refer to one or the other, and I'm just wondering which is it exactly? And maybe that has some to do with the baseline. And then the second question is, what are the impacts, if any, of the loss of collaboration with your Russian colleagues on the data in this report, and possibly future reports if that collaboration continues to be frozen, so to speak? That was a terrible pun, and I'm sorry about that.
For the first part of that question, I would like to turn to an author from the surface air temperature essay. I think Tom Ballinger was here. He may have left. Uma Bhatt is in the room. I don't know if Uma would like to answer that question, which is on the topic of what is the real rate at which the Arctic is warming relative to the rest of the world? Okay.
Could I try that one?
Sure. John Walsh.
Yeah, there are actually 3 factors at work that give these differences between the factors 2, 3, and 4. One of them is how you define the Arctic. You can choose 60 degrees north. You can choose the Arctic Circle, 66.5. You can choose the drainage basins. That makes a difference in what factor you get. The time frame, the exact time frame you use makes a difference, whether you use the last 30 years, the last 50 years, the last 80 years. And that factor also varies by season. So I think when these studies come out, they generally say what season, region, and time frame they use. But the answer to the discrepancies does lie in some combination of those 3.
The second part of your question, the impact on international collaboration with the geopolitical situation. I'm wondering if I can turn to one of our editors, Twyla Moon, to address that question.
Yeah, thanks, Matt. That's an important question, and we've seen varying impacts across different groups. There have been certainly groups that are folks who are traveling to Russia to take samples directly, and so we've had losses of direct observations, but also not only kind of potential restrictions or tentativeness in reaching out to colleagues, but also a recognition that collaborating with colleagues in Russia can be quite dangerous for them as well. So I would say this is an area that has influenced collaborations between people, also influenced direct measurements on the ground. And I think there's a lot of hope in the scientific community that we can find ways to continue to collaborate and move forward, but that's appearing quite difficult at this point. Do you have anything additional?
Well, I'll see if Rick Tillman online wants to add anything further to that question.
Yeah, thanks. A good question. Just to follow up on Twyla's response, it is important to understand that basic meteorological, climatological, oceanographic data continues to be exchanged at the same frequency as it has been. And of course, many of the essays in the Arctic Report Card rely very heavily on remote sensing. And that, of course, continues. So from the basic monitoring piece, things are okay. It's really that research, that person-to-person collaboration that has taken has had a big impact. But our basic, at least environmental climate monitoring, at the moment at least, continues.
This is Rick Spinrad. If I can make one comment as a policy guy here up on the panel. And the first is obviously that we condemn the aggressive activities of the Russian Federation. I also want to point out that NOAA as an agency has ceased engagement bilaterally with the Russian Federation since 2014 because of their aggression against Ukraine. And we are relying heavily, as are all the agencies that are part of this, on the global community through organizations like the World Meteorological Organization to ensure that the standards, if you will, for engagement are adhered to, and that everybody's on the same page in terms of working the issues that we talked about here today.
I'm going to take our next question from online.
Yes, we have a question from Ned Rosel at the Alaska Science Forum for John Walsh. Is less sea ice triggering the recent extremes in Arctic precipitation, or is it not so simple?
I couldn't quite make out the question. Could you repeat the question again?
Geez, is that better? All right. The question was, is less sea ice triggering the recent extremes in Arctic precipitation, or is it not that simple?
I think the loss of sea ice is contributing. That's how I'd put it. The fact that you have open water instead of sea ice means there's more evaporation that can provide moisture to the heavy precipitation events and to the storms. I think in terms of the actual storms themselves, there would be storms with or without global warming in the Arctic, and those storms would produce precipitation. But it's somewhat like the impact of the warmer waters on hurricanes. Hurricanes are becoming more intense, according to a lot of the tropical researchers. So there's a contributing role there, but not a flipping of the switch. That would be my take on the issue.
Hi, Morgan McFall Johnson with Insider. You mentioned that the Arctic is transitioning from snowfall to a rainfall dominant environment. And I know there was a study kind of putting a timeline on that about a year ago, but I wonder if you have a sense of how long until the Arctic is truly rainfall dominant. And what do this year's observations say about how quickly that transition is happening and what the most dire consequences of that are?
Well, I will turn to John here in a moment to further add to the answer, because I think he can probably speak to that, the real meat of your question, which is when can we expect this transition? There have been recent studies that have definitely shown that it's expected earlier than had previously been thought. I mean, one of the real implications of this transition is the blending of seasons. And so, as John mentioned, the rainfall event in December last year in Fairbanks created this ice layer that was a pretty notable disturbance in the middle of winter. Just last week in Utqiagvik, they saw 40 degrees Fahrenheit, so 8 degrees above freezing, in a community that at this time of year, the sun's not even rising. It was the coldest day on record for the period of November through March. And so that's not rainfall, but it does lead to melt in the middle of winter. And it's further tied to this question of how much this open water is contributing to precipitation. And so this increase in precipitation is playing out across all seasons, including, as John mentioned in his comments, a very heavy snowfall in North America over recent years. And I think it's important for us to put these individual measurements that are on the seasonal scale in a broader perspective, because as John pointed out, even with this large snowfall tied to increases in precipitation, we still are very quickly transitioning into summer with rapid snow melt in the month of June. So the interconnectedness of all these pieces is really where the partnerships are needed to come together and bring our observations together to create this bigger picture. But to the first part of your question, I'll turn to John about the timing of when we might expect a rain-dominated Arctic.
I'll just add to Matthew's comments that I think the answer depends on what part of the Arctic you're referring to. At the fringes, the transition is essentially occurring already. So in the next few decades, we're going to see a transition from snow to rain, and rain will become the major part of the precipitation yearly over most of the fringes. When you get to the colder regions, northern Canada and Siberia, eastern Siberia especially, it's cold enough that this increase in precipitation will be actually increasing the total snowfall during the winter. So if you were to map out the expected change in snowfall, it would be negative at the fringes of the Arctic, but positive in the coldest parts. So it's an interesting issue to look into. But I think there's no one single answer that applies to all points.
Take our next question from the online forum.
We have two questions actually from Melody Schreiber at Arctic Today. The first question is, following up on the earlier question about rain gauges, what investments need to be made, for instance, with ocean monitoring instruments, in order to understand exactly what changes are happening? And I'll read the second question after you respond.
Maybe Karen could address that question on the need for observations in the marine environment.
On precipitation specifically, certainly, there are in situ measurements that ships can make when they're out at sea. I think we do rely an awful lot on satellite remote sensing and reanalyses as well, as John mentioned earlier. But with increased sort of ship traffic in these areas as well, there are sort of increased opportunities to take measurements along the way. And John may want to say other things about sort of monitoring in ocean waters as well.
I just would add one other plug for this reanalysis approach, in the sense that an atmospheric model can perform as well over the ocean as it can over land, to the extent that it's assimilating some sort of observations from remote sensing or other sources. And I think that does offer the best potential. There are remote sensing products on precipitation. Most of them are from geostationary satellites, which do not see the Arctic very well. That's one reason we, in our precipitation chapter, did lean towards the reanalysis approach.
Hi, can you hear me? Yes, okay. Oh, close, okay, hi. Barbara Moran from WBUR in Boston. I'm wondering if any of you have pulled any good news out of the report.
Well, I wonder if Jackie might want to speak to that, because there is, I think, plenty of good news if you look in the right places.
It depends on who you're talking to, right? I think if everyone thought like an Inuit, you wouldn't be sad. Our Indigenous knowledge holders, our oral historians, share continually with us, and we pass them on now in my region for 500 generations, that, the world, the place we live in is constantly changing. But if you look at a geographic area in the Arctic where people have survived through all these changes for 20,000 years, and then we look at science, which is under 200 years old, there is hope. There's hope because people have survived that. And so I think the collective here and the message is that we need to share our knowledge, and we need to work together to create those triggers of hope. We're seeing things that in our generation, our ancestors had seen in multiple generations. And so we didn't monitor stress factors, but now we monitor stress factors as health indicators, and we try to heal them instead of adapt. And so I think that there is hope, and that I could still fill my freezers and eat the food that my ancestors have eaten for 20,000 years is hopeful. I want to make sure that that partnership with science is there so that for the next 500 generations, we have that same hope.
Take another question online. Anyone in the room, just raise your hand. I'll find you.
Yes, Melody Schreiber, Arctic Today. Her second question was, it's encouraging to see a greater partnership and focus on Indigenous communities. Why hasn't this happened earlier?
I guess I could answer that as well. I think it hasn't happened for a couple of reasons. Logistically, especially in Alaska, since we are the only Arctic state in the United States of America, we are logistically removed from road systems. So there's a twofold here. That has kept our culture intact as far as practicing our way of life. The second piece is no one really paid attention to the Arctic or listened to the Arctic people for a multitude of reasons. We were just so far away from everything. And so I think now what we're seeing is a shift in the dialogue and the narrative, and understanding that even through colonization and the displacement of our people, we still adapted and survived. So we have our language, we have our traditional cultural practices, but now we've mastered the Western world as well. And so now we could share and find new spaces to co-produce knowledge systems so that the future looks different. And that to me is just simply evolution of humanity.
Do we have more questions online, Becca?
We
Any
do.
reporters in the room?
Apologies if I mispronounce this person's name, but we have a question from Jocelyn Estes from Indian Country Today. Can you give examples of resilience in villages affected by climate change?
A good example of resilience is, I'm going to use whaling. So in Utqiagvik, which even though it rains, we still wear our furs if it's cold rain, because those animals existed in nature, right? And they went through storms as well. But if you look at the Umiat, the whaling vessel in which they hunt whales, the bowhead whale is unique to the Arctic. It is a staple of our diet for the Inuit. And there has yet to be a man-made material that is equivalent to that skin boat that is made through the process of traditional practice that has been passed on for thousands and thousands of years, that makes it silent in the water, and it interacts as a mammal to mammal through a permission and consent process. Yet that little vessel still hunts these ginormous whales, and the community comes together and pulls them up on shore. And that one whale is not only feeding that community, it's shared across the state of Alaska and even to relatives in the lower 48. So there is a process of resilience there in one traditional practice that has carried on for thousands of years.
A second question from Jocelyn at Indian Country Today. Can you give examples of instances where scientists, decision makers, and traditional knowledge bearers communicated and collaborated well?
The Inuit Circumpolar Conference has many examples of where this space has been utilized for a variety of sectors and responses, whether it's food security or recently they had a report out that really did bring in policymakers and looking at international collaboration. The uniqueness of that and those reports is that the Inuit are not only in Alaska, but they are in Northern Canada, Greenland, and Russia. And so you have on this planet an international collaboration that dates far beyond science. So I think those types of reports, as well as reports and publications that are co-produced by our search team, are reports that show that it can be done, and it has been done.
Can I give a very specific example that follows up on Jackie's point? One of NOAA's operations is the National Weather Service, and we have developed a product called Sea Ice for Walrus Outlook, which in working with tribes has met a particular need that is a direct consequence of climate change to ensure that the subsistence hunters have better information about the optimal route out on the ice as the ice is changing for the walrus hunt. And it really could not have been developed without the benefit of that dialogue and the benefit of the modern science that has gone into improving sea ice forecasts.
And I'll just add to that, as someone who's worked with the SIWO program, the Sea Ice for Walrus Outlook, that there's also so much that the science community is learning from the walrus hunters across the communities that participate in that program. And so that two-way exchange is really fundamental to how you would assess success of these types of partnerships.
Our next question comes from Yerith Rosen at the Alaska Beacon. Can you discuss the past year's tundra fires? How do you explain the abrupt change for the Yukon-Kuskokwim Delta starting in 2015? Are tundra fires the new normal?
I'm looking to see if JJ Frost, who's the lead author of our tundra essay, is in the room, and I don't think he is. So I will turn to Rick Toman if you're still online. Rick tracks a lot of these things and can give the best answer.
Hi, thanks, Yerith. As Yerith has alluded to, starting in 2015, we have seen a gigantic increase in wildfire in the Yukon-Kuskokwim Delta of Southwest Alaska. And all of the biggest seasons there have been since that time. I think it's a nice example, nice in quotes there, of how cumulative change is impacting some of these extreme events. As the elders are telling us, there is much more fuel, there's much more vegetation on the tundra now than there was 50 years ago. In the transition between the boreal forest and the tundra, the trees are growing farther away from the river. The trees near the rivers are larger. And as the fuels increase, as thunderstorms, which are lightning is the primary spark for fires in the boreal and tundra north, there's more fuel to burn. And so I think that's a big factor here, that we've, in the YK Delta, we've crossed some threshold. There is now enough fuel and we are getting enough lightning that things are burning in a way that they didn't used to.
And we have a question from Megan Gannon with the Nome Nugget. The National Weather Service has closed its offices in Nome and other cities in Alaska, now relying on volunteers or automated systems for direct measurements of metrics like snowfall and precipitation. Why isn't NOAA investing in better on-the-ground observations in the Arctic, especially in communities where people live? Are there any efforts to increase direct observations in the Arctic?
Yeah, thank you. This is Rick Spinrad, and the short answer is yes. One of the things I was able to observe in my visit to Nome in August was how we might take better advantage of some of the connections in the academic community with Nome, with UAF, to try to establish a training program at the local community college for building up observers and forecaster capability in Nome to complement the automated observing system that we have there. And I would say it's not just Nome, it's an issue that we're facing throughout Alaska in terms of building up the workforce, making sure we've got humans in the loop and taking best advantage of local workforce capacity.
Do we have any final questions from reporters in the room? Anyone? Last call? One more online. We're done. I'd like to thank our panel so much for this great presentation today, and to your colleagues online and here in the room for answering questions. And with that, we will close the session. Our next session will be at 1 p.m. and will be a media availability and briefing on the Mauna Loa eruption. And then there is a roundtable about the new solar telescope at 2 p.m., which will be in the roundtable room just across the hall. We hope to see you all there. And thank you again to the panel.